Good afternoon, everybody, and welcome to the Construct Innovate webinar series on innovation and entrepreneurship. My name is Jamie Goggins. I'm co-director of Construct Innovate, and we're hosting this webinar series in association with Engineers Ireland West Region. So, as I said, the topic of today's webinar is how startups are disrupting the construction industry. This is week 4 of a 7-week series. And really exciting today with our 3 speakers today. So our first speaker is going to be Mollie Claypool, who's co-founder and CEO of Automated Architecture and Associate Professor at the Bartlett School of Architecture at UCL. And she's going to talk about automated construction platforms for sustainable housing. With David Hunt, who's corporate lead at Vortech. So Vortech is a startup company related to aeration in wastewater treatment system, and he's going to talk about the Vortex power system. And then we have Leon van Berlo, who's the technical director at buildingSMART International, and he's going to talk about Open BIM and the new IFC 5. So we're going to have our 3 presenters for about 15 minutes each, and then we'll follow up then with the Q&A at the end. So if you have any questions for any of our 3 speakers, please do post it in the Q&A function that you'll see at the bottom of your screen. And as I said, we'll come to the questions at the very end. So without further ado, I'm going to hand over to our first speaker, Mollie Claypool, who's co-founder and CEO of Automated Architecture and Associate Professor at the Bartlett School of Architecture at UCL. So over to you, Mollie.
Great. Thanks so much for having me. So as mentioned, I'm Mollie Claypool. I am the CEO and co-founder at AUAR for short. And AUAR is an automated construction platform for sustainable housing. This is a great diagram for really explaining what AUAR does as an offer to the industry, which is that we have a software platform, I'll show you it in a second, that takes home designs from our customers and partners and translates them into robot code that then gets deployed in a robotic microfactory that can be set up either in a small facility offsite, in a larger facility offsite, or directly on-site for the production of timber frame panels, floors, walls, ceilings, and roofs for single-family up to mid-rise housing. We, as a company, maybe it's a little bit of a useful context to understand where we're at and what we've been doing over the last 12 months. So our position has always been that in order to be able to disrupt the industry, you have to not just develop a technology, but you also have to develop a business model that can help your customers scale. And a way to kind of demonstrate our traction so far is that in 2024, we grew 5 times, doing just under $1 million in revenue with an initial 4 partners, 2 of whom are builders and 2 of whom are developers. We have done some strategic press releases in late 2024 about what we were up to, which really demonstrated that we had quite a lot of interest from the industry with a huge increase in people that were contacting us, which has really put us into quite a privileged position, I would say, of being able to pick the right partners really early on to work with to start getting traction on the utilization of our technology. We also, because of that, have now this year a 10-time growth opportunity with 15 new partners in our pipeline. And what that looks like for what our partners are doing, which are primarily home builders across Northwest Europe and North America, means that we have about 600,000 square meters of homes in development across our customer network. So a little bit about us. So I have a background as an associate professor at UCL in London, where I met my co-founder, Gilles Retsin. We ran a research lab at UCL, which was looking at how do we develop new design to manufacturing workflows for using robotics in particular for developing homes that could be both sustainable and high quality as well as affordable. We've been joined by our CEO, Bridget, a couple of years ago, who has experience in scale-ups doing primarily B2B customer success and operations. She was previously the ex-interim GM at Anchor Store. And then we also work with a fractional CFO because we believe that, again, the financial part of what we offer as a business is really important, who is a 2 times executive founder and ex-HSBC called Jordy. And maybe one thing also to say about our team is that we have an underlying ethos at AUAR that in order to really change the industry, you need to reflect the composition of the world more accurately in who you have in your team. And we have a 50-50 gender split across the 22 members of our team, male, female, which is a really exciting thing, particularly in construction tech, and even more specifically within construction robotics, that we like to talk about. So the problem that we're looking at is like, why can't new homes be delivered at scale? And essentially the problem is that there is a lack of skilled labor, a really high labor cost and carbon cost, a lack of automation and fragmented supply chain. And what we're essentially missing out on as an industry is, over 100 billion in unrealized revenue across US and Europe. And what that means is that we have a really high need in terms of housing shortage in those contexts, but also a kind of fringe effects on how do we actually deliver housing that can be scaled globally to address the growing need. So the way that we do this at AUAR is that essentially we've developed a construction platform. And what that means is that that construction platform can impact up to the 60% of the total construction cost for home builders. The way that we do that is that we have a design to manufacture software platform called Master Builder. Master Builder does what master builders used to do, which is essentially design, engineer, and construct or create the documents for construction that are needed for home builders to be able to operate. And the way that we use Master Builder is that we as a company translate building designs into data that then gets run by our hardware side of our business, which is a robotic microfactory. Robotic microfactory looks just like this. It's essentially one robot arm that can fit inside of a shipping container with associate peripheral equipment around it that both can be essentially picked and placed and plugged into various settings. The way that we get that out to our customers, I'll talk to you in a little bit, but what's innovative about this is that it essentially takes multiple different kinds of manufacturing workflows and integrates them just into one single manufacturing workflow that can create many different kinds of building designs. And that's important because if you look at a typical offsite facility, you have to have mass standardization in order to make the money make sense for those facilities. And what we've been able to do is actually have a great amount of variability that can be produced by the microfactories and by Master Builder. That means that we can have high quality, sustainable, high performing timber homes that are able to be adapted to different kinds of sites at a significantly lower cost for our customers. I'm just going to show you in parallel two videos, which are essentially the software side of the business and the hardware side of the business. So on the left is Master Builder, and essentially what it does is it takes manufacturing parameters, structural engineering parameters, cost parameters, and design parameters, and it essentially takes the translation of those parameters and creates automatically manufacturing code. I'm actually going to skip ahead a little bit in this video. One of the ways that it does this is by Master Builder can be deployed as a plugin in Revit. So essentially in this video, which kind of skipped very quickly through it, you have a small house design, and essentially Master Builder will tell you where in the design is there a problem for this to be converted into manufacturing data, and it will tell you how to adjust the design in real time, and then automatically translate that into a fully buildable building that is pre-engineered and pre-calced with a full bill of materials, costing, etc., which means that you get completely de-risked manufacturing code as well as all of the kind of drawings and materials and data that a builder needs in order to actually build it. On the right-hand side is the microfactory. This is a microfactory that we've had deployed in Belgium since 2024 in particular. And what it does is it takes off-the-shelf timber material, OSB, and timber lengths. It will then cut that material to size, store the extra material as well in the cutting machine in the front end of the foreground of the video, and then assemble a one-side closed timber frame panel that can then be finished in the just outside of the robot cell to be taken to site. It can also build panels that are bigger than this now, so it can build entire walls or entire floor slabs. So it can do up to 4.8 meters in length and 2.4 meters in depth, which is really exciting. So we can actually have a huge amount of variability in between the smallest size panel that's possible and the largest size panel that's possible. The way that we get this out to our partners is essentially we're not builders ourselves. We are enablers as a tech company. So we have a hardware or design as a service model where we essentially charge our customers usage per square meter. So that goes for both design services. So they pay a per square meter cost for us to produce a design for them. And then they also pay a per square meter cost for the production utilizing the microfactories. And we get the microfactories to them in a rental model. So essentially what this means for them at the most basic level is that essentially they're just renting another piece of equipment and paying for a service that replaces a large amount of the costs of the design engineering costs that typically happen in a project at a much lower rate through us. We're targeting builders that are doing 50 to 200 homes a year. That number of 200 is actually a little bit low. We're actually mostly working with builders that are going up to 500 homes a year now. And what that means for us is that if a microfactory is used about 80% of the time over the course of that year, then AUAR gets about 500K in fees from each microfactory. And then the ROI for those builders are actually quite high as well. And so this is a full spectrum of kind of how we operate across design services all the way to manufacturing services. And these are just some images from some of the projects that we've been working on with our partners over the last couple of months. What this really means for the financial side of what we offer is that we create business cases with our customers. Working with us is oftentimes a very strategic decision for the people that we're working with. So we build these business cases very early on in our discussions with them to really demonstrate using validated examples that we already have from working with existing customers, what it really means for them to adopt AUAR. So the assumptions that we make are that we have an 8-hour shift for one microfactory. It's going to be used 80% of the time over any single day. It requires less than 2 hours of one operator's time. Working days per year is a standard. And then we take the square meter cost directly from Master Builder in order to make this calculation. And this calculation means essentially that if they have these assumptions, if they're working to these assumptions, they can produce about 44,000 square meters of timber frame per year with one microfactory. That equates more or less to 120 single family homes, and they have a 96% reduction in the FTE required in order to produce those that amount of timber frame. What that means is that for every pound that they spend working with us, they make 270 pounds. And over the course of a year, there's a 2.6 million ROI if you take into account the savings and the increase in margin that they benefit from by working with us. A little bit about also how we're addressing using LLMs in our work. So we have a kind of full stack DFMA integration using natural language programming. So what we've done so far is the beginning and end of this process, where essentially we can program Master Builder to use natural language programming to develop fully buildable walls that are buildable by the robot. So essentially you can write, I need a wall that's 3.9 meters wide by 3 meters tall with a wall and a window, and Master Builder will essentially use its database to calculate exactly what that needs to be. And then you can also edit that in real time as well with natural language. And that then automatically translates to generative manufacturing with the robot. And now what we're working on is filling the gaps. So essentially, if you have a generative wall element, you can easily then think about how do you get a generative design or generative layouts as well. Maybe a little bit about where, again, we're at. So we have 3 microfactories that are online right now in the EU and in the US. Those 600,000 square meters of homes in development across those 3 microfactories. We're delivering 5 new microfactories this year in the Netherlands, the UK, in Sweden, and where else? In Canada. So we're global from first go. And one of the things that's really important for us, has been really important for us, is really thinking about scalability at its very core. So at the core of Master Builder, I mentioned, is around building code as a parameter. So we've been able to develop essentially an API for timber frame construction, where all of the rules around building code are codified within Master Builder, so that we can essentially call to any specific amendment to code across countries that we need to make to work with our partners. And we're looking at essentially being able to deploy 5 microfactories per customer over the next few years. I'm just going to show a little bit about what we've done so far. So last year, we built a couple of 3 different projects. One was an interior retrofit project for a tech hub in Ghent in Belgium, which allowed us to validate the microfactory performance. We then built a 2-story house, some images of which you can see here. And then I'll show you a video of the project that we most recently delivered in a second. This is the 2-story house. This is a really interesting project because it allowed us to validate a lot of different kinds of panel sizes and what they meant for assembly on site, but also importantly allows to validate a model that can essentially be copied and pasted up to 6 stories. And we won an Innovate UK grant off of the back of this specific project that allows us to fully develop that mid-rise building system by the end of this year. And we've brought together a number of really interesting partners working around timber and mass timber in the UK to help us do that. And so we're really excited. Soon we're going to be releasing a white paper around the mid-rise building system and microfactory that we've been developing. And then the most recent project, I'll just show this video and I'll talk a little bit over it, was sorry, I'm going to try to sound up for myself because I know that you can't hear it, which was we were reached out to by KU Leuven in Belgium in 2024 to do a project called Constructor. Constructor is a new circular construction hub in KU Leuven that essentially is going to be a living lab for the adoption of automation and thinking about circularity and buildings and climate neutral building strategies. And so we developed the external facade panels for that project using our microfactory. And we're also going to be building a house there later this year where we can really test the circularity of our building systems, as well as think about how do you develop a carbon neutral building in its entire life cycle. So how do you develop a building that can be assembled and reassembled? How do you think about circularity on the material level versus the element level, et cetera? And we completed this project in January of this year, which was really exciting. So that's all from me. And if you want to see more, ABB, our automation partner, published a really great essay on why Constructor and why we've been working with them.
Brilliant, Mollie. That's very exciting stuff. Really impressive what you put together there, what you can offer, and that I'm sure lots of people have questions for you. So if anyone has any questions, please post them in the Q&A function at the bottom of the screen, and we'll come to those questions at the very end. Okay, great. So we'll move on to our second speaker. Second speaker is David Hunt, who's the corporate lead at Vortech. So very different technology, but another disruptive technology as well. So over to you, David.
Okay, great. So yeah, as Jamie said, I'm the corporate lead for Vortech, which provide vortex powered aeration to the wastewater market. We do municipal and industrial installations. The other bit of my background that's relevant, I teach about disruptive technology for Singularity University, which is a technology think tank founded by Ray Kurzweil and Peter Diamandis. And in that, the fundamental aspects that you look for in a disruptive technology is something that is better, cheaper, and simpler, and addresses a major global problem. So it is fully scalable once you've got your problem solution fit. And Vortech represents a technology that ticks all of those boxes as applied to the global wastewater industry. So just, I think most people are generally aware, because it's in the news all the time, just what a problem wastewater treatment is globally at the moment. And just to give you a bunch of stats, because all engineers love stats, the global waste, currently only about 20% of our global waste streams are treated. And about 80% of our global population has access to treated water. And in terms of revenue, it's a 250 billion annual market. The area that Vortech targets, wastewater aeration, is a 20 billion annual market that is currently growing at a 6.8% compound annual growth rate. In terms of global impact, wastewater today uses up approximately 2% of our global energy use, and the aeration function is 70% of that. So these are significant areas of growth and significant areas of problems, and it's something that humanity needs to solve to create a fully sustainable long-term culture. So the big issues that we have in wastewater at the moment is how quickly we can scale it. So facility owners, they have increased volumes that they are required to treat, because more human population equals more poop, more industry equals more waste as well. So we're operating in an environment where we have more and more volume that requires more and more stringent regulations. and we need more capacity that is dealing with the wastewater in an increasingly environmentally friendly fashion. So facility owners are challenged on a whole bunch of different facets. First of all, they need to upgrade their facilities as rapidly as they can. This comes in two formats: retrofitting old facilities as well as doing new greenfield sites. Aeration needs to be extremely energy efficient. As mentioned, 70% of the wastewater treatment function is aeration. So any costs savings there massively save the cost of your overall function. And maintenance is a massive issue. A lot of wastewater treatment facilities try and have as few people on site as possible for very good reasons. You don't want to be too near wastewater a lot of the time. So encouraging lower maintenance costs and reducing the need for maintenance at all is extremely important. And finally, longer life expectancy. So when you build a new wastewater facility, you want it to last 50, 100 years with minimal need for upgrades or improvement after the fact. So who are Vortech? We are a team of people that have a bunch of multidisciplinary expertise in fluid dynamics, process science, and digitalization. The company originally started offering fluid dynamic modeling for wastewater companies, doing consulting because that's how a lot of startups get to market. They provide consultation, and that allows them to build and refine project work that's going on in the background, and eventually it enables you to launch a product. So Vortech created an innovative technology that leverages vortex flows to introduce oxygen into water. And one of the reasons that has been so disruptive is because of how efficient and simple it is. So if we go into and look at how wastewater aeration has been done historically, it was originally done using rotating mechanical aeration, which is like a paddle that froths the top of the water. And you can see that image on the left depicts it. Again, kind of disgusting, having all that spray everywhere, and it's extremely noisy. The more recent technology, which is the kind of dominant technology at the moment, is fine bubble diffused aeration. It kind of like makes a wastewater jacuzzi. So you put a load of diffuser heads at the bottom of a tank. You have an entire building full of pumps that pump air into their diffuser heads, and they allow air to go up through the water. So it's bringing air to the water. It's very noisy. It's very complicated. It's very energy inefficient, and it also has a lot of maintenance issues because as those diffuser heads in the right picture that you see get clogged up, that increases the energy usage, and those diffuser heads need to be cleaned, which either involves draining the tank, which causes you loss of process for the length of time that takes, and also your other option is sending a diver into the tank. And trust me when I tell you, going diving into a wastewater tank is not a popular activity that people want to do. So what have Vortech done? We've married the best of both of these two technologies to create a brand new product. So the Vortech VPA unit is surface mounted. So it's on the top of the unit. So it's on the top of the wastewater tank. So if anything goes wrong, you don't need to go into the tank to deal with it. And it provides the high quality fine bubble aeration that diffusers are able to do simply by leveraging the vortex flows through the shape of the tank. So while you might have hundreds, if not thousands of diffuser heads at the bottom of a tank backed up by a load of blowers, we can replace that with a single Vortech unit that is made up of 3 parts and a pump. So this is where I'm talking about the simplicity aspect of disruptive technology. The Vortech unit is incredibly simple. You can see the 3 parts here. We've got the inlet column, the circulation chamber, and the outlet duct. So we use the pump to flow the water. Some of the pumps in our larger units can be transferring up to a ton of water per second, is how big these units get. You'll see some images later on that'll just show you just how big these are. And our ability to take air from the atmosphere by making that vortex in the unit and then sending the air down into the wastewater tank gives us much, much more precise controls than what is capable with the legacy technology. And it also uses dramatically less energy because instead of pumping air, we're just taking atmospheric air. And again, the kicker of making things simpler and reducing maintenance, because there is only one moving part, which is the pump, we have a single point of failure instead of hundreds, if not thousands, points of failure in the form of the fine bubble diffused aeration. So generally, when our customers install these units, they install them and then they forget about them. You have to do periodic maintenance of the pumps, and the unit itself is spec'd to last 30 years. The pumps last approximately 15 years. A lot of our customers insist on having a standby pump on site, but we still haven't had an incident yet where those standby pumps have actually been required. So again, a much, much simpler tool to operate that gives you a much, much better outcome than the current alternatives. And to be a proper disruptive technology, it's not about just building a product. Your ability to deliver that product is incredibly important. So with Vortech, we have outsourced our manufacturing entirely, and we have manufacturing capacity in Vietnam and also in Poland. And when we get an order to the client, they specify the oxygen demand, how much air they need in their aeration tank. We select how many units and what size. And then the client sources the platform and panel. So that's a civil engineering job, deciding how the customer wants to fit the unit into their site. And it's their civil engineering partners that provide that service, not us. We send the units on a flat pack ready for assembly, and it takes approximately 24 hours per unit to install. And we don't even have to go on site to observe these installs at this point because we're so confident in the ability to execute. Just it's kind of like, let's call it the IKEA approach to wastewater aeration delivery. I'm not going to show you this video just because we're a bit tight on time, but if you go to our company webpage, you can see some very nice videos that demonstrate how the technology actually works. But these are the overall impact that our customers have enjoyed. And again, this is why this technology is so disruptive. This is why Vortech's revenues are currently growing at 98% compound annual growth rate since we started selling. We have a 80% lower installation time. And not included in that is just how simple the engineering is. We're not laying pipes. We're not building entire blower houses to house the pumps for the aeration unit. It's simply drop the unit in on top. There is no loss of process, no loss of service for retrofits. You can literally put one of our units on top of the tank, turn it on, and turn the FBA system off with zero loss of process. Energy reduction is 30%. In some of our sites, we've recorded over 40% energy savings. And the maintenance costs, as explained, are dramatically reduced, and the life expectancy is double what you would get from an FBDA system. All of these numbers here are the averages coming from real commercial VPA installations over the last 4 years. And again, one of the points that is so compelling about the Vortech installs, we never did any pilots. We went straight to commercial installs, largely because the product was so simple and compelling. We did not have to convince people to try the product. We went straight to commercial from our test site phase, let's say. So in terms of where we apply the technology, because its simplicity allows it to be extremely generalizable, we're extremely cost competitive for new builds because we don't require blower houses, blower buildings, or all the civil works or mechanical assemblies associated with rival technologies. So we've a massive CapEx saving on a plant-wide basis. For retrofits, the principal savings from using us versus renovating what you already have is the amount of OPEX savings you get from your operational costs, as well as the zero loss of process when you're doing the install. And again, because we are so quick to install and because the length of our lifespan, you can dramatically increase the capacity from installing a VPA unit while also reducing the total life cycle costs. And today, the system is fully generalizable for pretty much any wastewater aeration process you can think of. We can work in MBRs, oxidation ditches, plug flows, you name it, we're deployable there. Our largest scale installation at the moment is a 250,000 population equivalent site in Western Australia. And again, just to demonstrate how we operate as a company, there's 15 of us, and we are selling and installing in the UK, Australia, Ireland, and continental Europe. We're very soon going to be operating in the Middle East and North America, again, with minimal increase in our company size. And this just gives you a sense of how the technology scales for people who like the numbers a bit more, and apologies for the resolution on this. But this is basically showing you we've got 8 different size units, and this shows how it scales to how much water we can process, how much effluent we can process relative to the overall size of the unit. So we actually we benefit from greater cost efficiencies the larger the unit scale. And again, this is why what we have is such an exciting technology. On a longer term basis, you can potentially do wastewater treatment on a building by building level, because we enable you to shrink the aeration process into such a small footprint. Conversely, the degree to which we can go larger and larger and larger facilitates doing more centralized waste productivity as well. So whichever way the market ends up going, decentralized or centralized, we have compelling cost and efficiency advantages versus any other technology that exists today. I'm not going to go into the case studies. I'm just going to finish up there. But just to reiterate once again, this is why Vortech is a disruptive technology that is being bought over and over again. We make the lives of our customers easier. We make the lives of the civil engineers that install the systems easier. We're cheaper, we last longer, and we give a better product output in terms of wastewater treatment, aeration, and effluent management.
Brilliant. Thanks, David. Very exciting. Again, you can see the parallels between the technology that Mollie's talking about for construction of buildings and the technology that David's talking about. Very different applications, but I mean the secret sauce for both of those is the scalability there in there, and also you know, that it's not just focused on one small sector as well. Very good. So I'm going to go hand over to our third speaker, Leon van Berlo, who's technical director at buildingSMART, and he's going to talk about BIM and IFC. So over to you, Leon.
Thank you. I think you should be seeing my screen by now. So
yes.
Yep. So yeah, title of the whole session is on how startups are disrupting the construction industry. But as Jamie already said, this is the technology I'm presenting is more like a backbone technology to be able to actually help startups facilitate the construction industry. So my subtitle is how startups are disrupting the industry thanks to OpenBIM. I'm not sure how many people understand what OpenBIM is or heard about it or know what buildingSMART is. I'm not going to do a 2-minute introduction. I'm actually going to do a 10-minute introduction about this. I think the whole principle, as also Mollie has presenting in the first presentation, is really about automation. So we all know BIM. We know that you're going to author data with some kind of authoring tool manually. And then the whole principle is to send that data to some kind of a processing tool. And the best way for our industry is that that processing tool can actually process this without human intervention, without having to have a human on that side of the tool, and really produce some kind of a result within seconds or minutes. And in this case, the arrow points back to the authoring tool, but obviously it can also point back to the user directly, or as many people would prefer these days, is that you send it back to a CDE. So the data comes from a CDE into some external processing tool and gets back. My claim is to do this at scale. You can't just send data, but you have to send some kind of standardized data. And of course, from a buildingSMART perspective, we think that should be IFCs, industry foundation classes, which is basically standardized as the backbone core foundational principles and classes for our industry. These processing tools can be anything. There's a lot of different processing tools. Usually they're somewhere in the cloud, and they're different per region. It could be a lot of different things. I mean, the robotics from Mollie's presentation, of course, can also be this online processing tool, as we saw, but we have energy simulations, permit checks, cost estimations. All of these are based on national requirements or regional inputs, or just ways of working that are different in the Middle East compared to Asia or Europe or North and South America. So all of these processing tools have a different way of processing the data, even though it's the same data that you send to it. Cost estimations or scheduling will have different outcomes depending on the region. So we cannot have one standard tool that does energy simulation or one standard tool that does CO2 emission calculation. There are many, many differences in these tools. And that's the nice thing about our industry. That's the beauty of a fragmented industry. You have a lot of means to innovate. But if you have to build a separate data standard every time for every tool and have to ask this guy or girl on the left side to produce data in a different way every time, then you're really losing the productivity, of course. So the whole principle to have this possible is that on the left side, you produce data in a standardized way, and then on the right side, you deal with that standardized data. One missing component next to just sending IFC is obviously this API, a programming interface to be able to send that data towards an online tool instead of having to program against different APIs every time. So this is the position of buildingSMART. You should have standardized definitions of data, of classes and properties, and you should have a standardized API to which you can send data that then processes it and sends it back. So the prerequisites of doing this, so the prerequisites of having such an ecosystem where anyone can create these kind of tools and niche applications to automate whatever is necessary, is to actually have these openly available definitions, openly available definitions on the data and on the interface, and even a protocol to send back the results. And this is where OpenBIM comes in, because from our perspective, openly available means accessible to all. So all of our definitions are freely available. They're ISO standardized, so they're created by a transparent process, and they're vendor neutral. So this combination of having it openly available, created vendor neutral, open processes, transparent procedures, and having both the data and the interfaces standardized is the umbrella term that we use. It's called OpenBIM. There's many different standards in this OpenBIM ecosystem. We have IDS to define requirements for data. We have IFC, which really defines the data exchange standards. The BIM collaboration format is a format that you can use to get back results, or results from simulations, from clash detection, from energy simulations, whatever. And the OpenCDE term is an umbrella term for the different APIs that we're developing. So this is already available now. I think many of you are at least recognizing one or two of these terms, but this is something that works almost out of the box in a lot of software tools already. Then a few words on what the future would hold, and this is indeed mainly focused on version 5 of IFC. This is a very technical topic, but to just give you a bit of a principal objectives, what we really need in IFC 5 is this predictable processing. So if you want to have this automated workflow with online services that produce results within seconds or minutes, this receiving software really needs to understand there is no way that a human intervention can happen, and that the processing should wait for a human to make some decisions and tell the software how to make an interpretation. So There cannot be any ambiguity or human interpretation on that side. And this is, I mean, in all honesty, where IFC4 has been lacking a bit, because there's multiple ways to do things, and automated processing has never been the top priority use case for IFC, which it should be. And that's really what IFC5 brings to the table as a top priority. Easy to implement is also a top priority for IFC5. As many of you may also know, if you try to implement IFC4 or 4.3, 2x3, it takes a while, depending on which toolkits you use, depending on which technology you try to do it. It takes at least a couple of weeks, but usually it takes a couple of months. The harder it is to implement, the less reliable the implementation gets. So as an objective, easy to implement, it basically means it has to be a very reliable implementation. And the only way to measure reliability of implementations is how easy it is and how fast people can implement it. So this is a top priority. And then as a final top priority, it should be one standard, not just an exchange standard, but really a data model for the whole industry. So it's not just coordination and bringing together multiple IFC files to do coordination. This really is about automating these processes as a top priority. So again, for startups and to facilitate startups to disrupt the industry, this easy to implement is really a KPI that is extremely important. If you have startups that can create a Revit plugin within days, they should be able to create an IFC application within days as well. Otherwise, it will never scale and it will only work on one software tool. So this is a top priority for IFC5 to be able to really accelerate the growth of this ecosystem. That does mean that we're going to make it hard on ourselves, because getting from the current IFC to an IFC that really facilitates these use cases and these objectives, there are some steps to make. But that's what we're here for. We really have to do the hard work so it is easy for others, easy for startups, but also easy for already established industry partners to do this. So if you're interested in what we've been doing, I can talk hours about IFC5. I'm happy to do it as well, but in this presentation, I only have 10 minutes, of which, 15 minutes, of which 10 have already passed. So have a look at this link at the bottom. So this is where you can find all of the current examples, and this QR code would brings you to a placeholder for a course that we're also developing to really get your hands onto IFC5, what it means, what kind of impact it has. To just quickly go over what it would bring, some of the new use cases are incremental updates. So people that have been working with IFC know that if you export to IFC from your authoring tool, you make a couple of changes, you have to export whole model again, even if you only have minor changes. So IFC5 will make it possible to then only update the changes that you made, which massively speeds up the exports and the exchange, obviously. This automated processing is extremely important, and we also want to have it. We want to make it easier for people to reuse objects as a type to be able to also scale faster. Then beyond the first version of IFC5, eventually we also want to create an integration of IDS and BCF. So this has to be explained a little bit better. Again, for which I don't have the time at the moment. But when you look at IFC5, it's really a composition of different objects. You can even add point clouds objects to it. You can add your own custom properties to it. You can add different kinds of geometry to it. So if you have an IFC5 data set, you can see the designed geometry. You can switch to the engineered geometry by the manufacturer. And you can even also add point cloud geometry, how it is installed on site. So IFC5 allows all of these things to be packaged within one composition. And if you have that principle, it's really not that hard to also add requirements to that object. What were the original requirements for that object, or what are the issues that we have on these objects. So these use cases where you have a separate standard for requirements, information delivery specification, or you have a separate standard for what are the issues and what are the topics. These separate technologies and separate standards in the future are also going to be integrated into the new IFC5 standards, where you can then, with one data format and one API are able to exchange all of these different use cases. So same data format, same API, you have an integrated offering. That's what's coming to the table within the next couple of years around IFC5. I'm personally very excited about this. Some basic principles, I put this slide in because the slides are going to be shared. I'm not going to go over all of them, but this is a bit of the principles of what I've been telling. Maybe as a wrap up in the final 2 minutes that I have, just to show you that OpenBIM is more than just IFC, but it's also more than this IFC plus IDS and BCF that I just spoke about. When you look at the whole ecosystem of what buildingSMART is offering, it's not just the standards of IDS, IFC, BCF, and the APIs. We have a translation service as well. There is our buildingSMART solution for data dictionaries. We have a use case marketplace. We have a validation service to check if your data is actually constructed according to the standards. And we also have this whole professional certification program to educate users how to use things and to even get them certified as well. So with 1 minute left, again, I can talk hours about all of these topics, but I think the message of the presentation that I wanted to give is how are startups disrupting the construction industry at scale. I think that's really thanks to this OpenBIM framework that we're offering. If you want to know more, please visit us at buildingsmart.org or just send me an email or WhatsApp, whatever you want. I'm usually pretty available. Thank you.
Brilliant. Thanks, Leon. And great to have you guys doing all the hard work, because a lot of us take great advantage of other people's hard work and then and reap the rewards of it again. So glad it's you that's taking the pain and not me. But yeah, we can see from the work we've done in terms of the IFC and using those and trying to create plugins and so on, that having IFC version 5 that's predictable, easy to implement, and I suppose standard model is sounds like Havana in there. So